Hi, everyone. The article that we've assigned you to read, the Walker et al. Piece, looking at the effects of cognitive stimulation and nutritional supplementation on a sample of children in Kingston, Jamaica, introduces a couple of key concepts from the world of quantitative evidence, and we'd like to discuss some of those in these videos. So the first thing I want to talk with you about is this idea of causal inference. I'm going to talk about what we mean when we talk about a causal effect and how we detect that. So the specific framework that we're going to be introducing is something called the potential outcomes framework, or to be really technical, the Neyman-Rubin potential outcomes framework. And the basic idea behind this, what it does is it gives us a way to define a causal effect, which then gives us a way to estimate a causal effect. So this is one, but a very influential way of thinking about what it means for an intervention to have a causal effect. So the basic idea here is, imagine looking at the figure of the child on the left-hand side of the screen. Imagine that there is a child who's been enrolled in this study. They qualify for the study. And at this point, they're about to be assigned either to receive cognitive stimulation, nutritional supplementation, or the control group, which didn't get either of those two things. So what the Neyman-Rubin framework asks us to do is to imagine that this particular child at this point actually has three different outcomes that could be observed. Outcomes here being on some particular variable. Let's say, for instance, that we're looking at their outcome on some sort of a math test. So if this child is assigned to receive cognitive stimulation, then when we administer this test later on, there is some particular outcome that the child will have, whatever it is. It's like a 10 on the test or something. But this is, and it's crucial to remember this is not the only potential outcome that the child could have, because the child could have instead been assigned to nutritional supplementation. And if we had assigned the child to nutritional supplementation, she or he would have had a different outcome at the follow-up, a different score on the math test, maybe higher, maybe lower. And similarly, had this child been assigned to the control condition, there would be yet another outcome that we would therefore have observed about them. And so this is the idea behind the potential outcomes framework. There are multiple different outcomes that any unit could experience depending on which condition they're assigned to. I think a more traditional experiment uses two conditions, a treatment condition and a control condition. In this case, we have three different arms of the treatment. So there's two different treatment conditions and one control condition. And so this idea of potential outcomes is also useful to us because it allows us to define what we mean by a causal effect. And specifically, a causal effect is the difference in the outcome that we would observe under one condition versus another. So if I want to see the causal effect of assigning a child to cognitive stimulation versus nutritional supplementation, the causal effect for this particular child would be defined as the difference in those two potential outcomes. So you literally just take one score minus the next. Now, that's helpful for us because it helps us to define a causal effect, but it doesn't necessarily help us to calculate a causal effect. And the reason for this is something known as the fundamental problem of causal inference. So what it's going to turn out is that as soon as we have assigned a child to one condition, we have guaranteed that we cannot observe their other potential outcomes. So if we've assigned a child to receive cognitive stimulation, then necessarily we have not assigned that child to receive nutritional supplementation. We have not assigned that child to the control. And so although at the follow-up we'll be able to observe one of these potential outcomes, there are two that will remain hidden from us. And so essentially the problem for us is that we need two potential outcomes to calculate their difference. We're in a situation where we can observe one potential outcome, but not the other two. And so we won't be able to estimate or measure any of those treatment effects. So the causal effect is well defined, but we can't measure it for any given unit. This is almost always true. And that's because we can only observe one potential outcome. However, there is a solution to this, or at least a partial solution to this. So instead of focusing on the causal effect on any given unit, we tend to focus instead on the average causal effect. So the average causal effect across all units in the sample. And the way that we're going to estimate that, the average effect, is we're going to take the average outcome of units who are assigned to cognitive stimulation minus the average outcomes of those who are assigned to nutritional supplementation, and that will give us an estimate of the average causal effect of cognitive stimulation versus nutritional supplementation. A reason that this works is that we have randomly assigned units to the 3 different conditions, and what that means is that the potential outcomes that we observe for those who are assigned to nutritional supplementation are good proxies for the potential outcomes that we would have observed among those children assigned to cognitive stimulation if we had assigned them to nutritional supplementation. So essentially, we're allowing units who were assigned to one condition to act as proxies for what would have happened to units assigned to a different condition if they had been assigned to the first condition. This allows us to estimate causal effects. We're going to talk a little bit later about some of the techniques that we use to see whether or not the differences that we observed are due to something more than just chance. Because the people who are assigned to nutritional supplementation probably do not have the exact same average outcomes, potential outcomes, as those who were assigned to cognitive stimulation just by chance. This is why random assignment is so crucial, or techniques to sort of replicate random assignment. The reason being that if we had allowed units to select which treatment they received, we'd run the risk that units that selected into nutritional supplementation had systematically different potential outcomes than those who selected into cognitive stimulation. And that would make it impossible to use them as proxies for the cognitive stimulation group. So in this video, we've talked to you a little bit about what we mean by causal effect. We've talked a little bit about how we can use experimental design to detect a causal effect. And we've talked about why we tend to be interested in average causal effects rather than the causal effect on any given unit. Thanks for listening.